Hey guys, section 9.2. Okay, here is your little helpful tidbits for the day. So section 9.2, we're looking at simplifying radicals. So these are going to be ones that probably aren't going to come out to be a whole number. So we've got two rules that we're going to look at to start with. Okay, so basically if we have two terms that are being multiplied underneath the radical, if we wanted to, we could take the square root of each of them separately, and since they're being multiplied, those would still be multiplied together. This rule works out really nice. The same thing holds true if we were dividing two numbers underneath the radical. We could divide each of the separate radicals like that. Okay, unfortunately, this rule doesn't work if they were being added or subtracted. Not going to try to trick you or anything with these to start with. They're all going to be multiplied for what we're going to do today. Okay, so you ask yourself, square root of 48. First thing you do, you rack your brain, you say, okay, does it come out to a whole number? Sadly, no. So our goal is going to be to try to break it down using this rule into two radicals. Hopefully, one of those radicals, our goal is what we would call a perfect square. And I don't think I used that term yesterday. I probably should have in the 9.1 explanation. Perfect square is a radical so that we do have a whole number answer when we take the square root of it. So for 48, I'm going to break it down into a product of two different things. Now for 48, I've got some choices. I could say, well, 48 is 2 times 24. But neither of those is a perfect square. 2 doesn't have a whole number square root. 24 doesn't have a whole number square root. So I'm going to try to think of something else that goes in. Well, how about 4? 4 does go into 48, and I know 4 is a perfect square. The square root of 4 is 2, so that helps me a little bit. 4 times what gives me 48 now? It would be 12. So square root of 4 is 2, and I have the square root of 12. Now, it just so happens that on this one, I didn't pick the biggest perfect square that was contained in 48. So I need to do this process again, because I'm looking at 12 and saying, I think I can break down the square root of 12. I can call the square root of 12 the square root of 4 times the square root of 3, because 4 times 3 gives me 12. There's still a 2 in the front. That 2 is not under square root. So as you're doing these, be really clear which ones are under a square root and which ones aren't under a square root. The square root of 4 is 2, so this is a 2, and everything's being multiplied, so that's going to get multiplied by the 2 that was already there. And then we have the square root of 3. I'm hoping I'm not writing too small and that you can see this. 2 times 2 is 4, and then that root 3 just gets written next to it. So we have a 4 that's not under a square root and a 3 that is under a square root. Now, just as an aside, if instead of picking 4 and 12, if I had picked the biggest square that goes in perfect square that goes into 48, we could have actually called this the square root of 16 times the square root of 3, and the square root of 16 is 4 root 3. So here we would have done it in one step. Over here we did it in 2 steps. We get the same place. It's kind of like we talk about. Sometimes you don't always find the quickest way to get there, but as long as you get there in the end, that's fine. Second one, I've got two terms that are being divided. The top one has a square, is under a square root. The denominator is not. So we're just going to let that denominator hang out down there for now. It's a 3. The square root of 18, let's do the same process we just did here with the 48. So the square root of 18, let's call that the square root of, let's go 2 times 9. Now in this case, 2 doesn't have a whole number square root, 3 does. The square root of 9 is 3. So I've got a root 2 and I've got a 3. So the 2 is still under the root. The 3 is not. Be really clear when you write those. And we've got the 3 down here on the bottom. Those 3s, since neither of them were under square root and they were the same exact thing in a fraction, everything's being multiplied, we can cancel them off. So all I'm left with on this one is the square root of 2. Now I've got one up here, both my numerator and my denominator are under the radical, so I'm going to write them separately. Root 7 on the top, root 16 on the bottom. Root 7 doesn't have a whole number answer, so that's just hanging out like it was. Square root of 16 does have a whole number answer, and that's 4, so that's not under a square root anymore. There's no reducing I can do here, so that's my answer. Radical on the top is okay. I'm going to get to a problem down here in a minute. Radical on the bottom, we don't want to leave that. It's not considered simplified. Now on this problem, we have the square root of 32 over the square root of 50. I could do it like we did the last problem, taking the radical on the top and the radical on the bottom, but I'm going to give you a little helpful hint. If we do that, that's going to be a little bit more work. It's kind of like the long circuitous route. Quicker way to do this, there's no reason why, if this fraction is reducible, that we can't reduce it first before we split and do the radical on the top and the bottom. So it looks like 2 goes into both of those terms. So let's go ahead and divide the top and bottom by 2 first. So everything is still under the square root. 32 divided by 2 is 16. 50 divided by 2 is 25. Can you see how much nicer this is going to be now? If I now do the separate square root top and bottom, the square root of 16 is 4. The square root of 25 is 5. And so that worked out real nice. Last problem. Both are under a square root, so I have a choice right now. Let me do this 2 ways for you actually, okay? If we wrote it in the opposite direction, since they were split to start with, I could go the square root of 100 over the square root of 5, and I could then reduce this and call it the square root of 20, and then reduce the square root of 20. 20 is root 4 times root 5. So 2 root 5. The other way that I could have done this problem is if I had looked at this and said, I know the square root of 100 is 10, and I have root 5, and root 5 doesn't come out to be a whole number answer. But this is the case where we don't like radicals in the denominator. It's one of those just rules mathematicians came up with so that all of us have answers that look the same. Because if one person had done it this way and came up with 2 root 5, and somebody else reduced separately top and bottom and came up with this, those don't look alike. So the rule mathematicians came up with is that we don't want radicals in the denominator. And so if you end up with one in the denominator, the way that you get rid of that, it's a process that's called rationalizing. And what we do is we multiply by whatever we have on the bottom. I'm going to multiply the top and the bottom of my fraction by that radical 5. If I do that on the top, 10 and root 5, 10's not under the root, so that's just going to be out in front still. But on the bottom, if I have root 5 times root 5, that's the same as the square root of 25. And the square root of 25 is just plain old 5, and so that made the radical go away. If the radical has gone away now, the 2 parts of this fraction that are not under a radical, we can divide those. 10 goes in, 10 divided by 5 is 2, so I will get 2 root 5, which is the same answer that I got when I did this the other way. There you go. Hopefully that's helpful to you. Have a great day, guys.